Okay, so I wanted to start today with this, and I wanted to sort of build on this particular question before we jump into the next question, because the sort of last part of what it is that we're going to do this evening is actually quite difficult. And I also just wanted to demonstrate through the use of this question why your grade 11 circle geometry is so important. Before I sort of jump into, as I was saying, what I'm going to do for the rest of the evening. Okay, so this particular question here tells us that PB is a tangent to the circle. So the moment we read the words tangent, we need to start thinking about our grade 11 Euclidean geometry. What can you remember about tangents or some theorems about tangents from last year? So just some ideas from you guys. What does the word tangent bring to mind in terms of theorems? There we go. Tan chord theorem. Yeah, that's the most obvious one. Lovely. I'm so pleased you guys said that. And those of you that said tan chord theorem, can you remember how tan chord theorem works? Do we recall how tan chord theorem works? Or are we kind of just working in the blind here? Do we remember tan chord theorem? Yes or no? Thumbs up, thumbs down.
Let's go, guys. We need to let us know so teacher Lee and I can know. There we go, Linova.
Okay, so
yeah.
The Makler says no. Itandile says no. Sarah says no. Angelique says no. Okay. No, I'm glad. I want you guys to be honest.
Yes.
Chepo, no. Annie, no. Okay. Shomokelo, you're the only person who said yes so far. Okay. So what I'm just going to do very quickly then is I'm just going to go back here. And sorry, this is just based on your answer. Okay, let's look at that one. Let's just, where is it? Converse theorems. Oh, there it is. Okay, so this is the one that I'm looking for. All right, so here in the middle of the page, right, this is tan chord theorem. I've just rubbed the yellow out. Okay, so this is the idea. All right, here is the tangent. We have been told that TA is a tangent. Okay, so tan chord theorem tells us that the angle between the tangent and the chord is BT. Okay, so AT is the tangent, and the chord that we're talking about, let me just rub it out and not make it purple. I'll make it a different color. The chord that they're talking about is this line over here. And the angle between these two is this one that I'm drawing in green. There's the angle between the tangent and the chord. And what it does is it subtends an angle in the alternate segment. So from T to C and from B to C at the circle. Okay, the angle over here, angle C, is the angle in the alternate segment. So that's what tan chord theorem does. It tells us the angle between the tangent in pink, the chord in yellow is equal to the is equal to the angle in the alternate segment. Okay, so that's how tan chord theorem works, and it works both ways. So in other words, C is equal to BTA and BTA is equal to C. All right, does that make things a little bit clearer for everybody? Are we feeling a bit happier about tan chord theorem? Thumbs up, thumbs down? Yes, just that little reminder. Okay, so we can see now which is the tangent, which is the chord, and which is the angle in the alternate segment, and then hopefully the angle between the tangent and the chord. Okay, so what you are looking for is your tangent. From your point of tangency, you've got a chord, and then you've got an angle in the alternate segment. Okay, so it's going to form a triangle inside your circle. All right, so let's go back to this. Right, they have told us that PB is a tangent to the circle. So again, look at this. Here is your tangent. Let's put it in pink. Okay. Here is your chord. Let's put it in yellow. Okay, and then remember this subtends an angle at the circle. So from B to C and from A to C as well. Can you guys see that more clearly now? I hope so. All right, so the angle
on my side.
The angle between the tangent and the chord is angle B1, guys. The angle in the alternate segment is angle C. All right, so the orientation and the way that it's been drawn is just a little bit different. It's maybe not as obvious, but there it is. Okay, hopefully now that's better for you. All right, so when they say that PB is a tangent to the circle, quite right, they want you to start thinking about tan chord theorem, because tan chord theorem proves that angles are equal, and that's obviously useful to us in similarity and in trying to prove similarity. If they use the word tangent, there are a couple of other things that you would also need to think about as well, although not in this particular case. So if they use the word tangent, you could also think about radius perpendicular to tangent if you needed to. And the other thing that you could think about is tangents from the same point. Tangents from the same point are equal to one another. All right, so that is also sometimes useful in proving similarity. The other thing that they've given us here are parallel lines. So straight away, when they tell us that lines are parallel, what kind of angles do we start thinking about? What sort of angles are we thinking about here? Angles that prove that things are equal. So parallel lines, going back to grade 8 even, what angles do we think about? Matrix, you can pop it into the chat. Yes, so the fun angles, Linda Couchet, quite right. So in other words, the angles that I'm referring to are alternate angles, or we can also think about corresponding angles, because both of those, yes, Tundleware too, yes, because both of those are equal. Okay, alternate angles are equal and corresponding angles are equal. So the fact that we've got equal angles here is really important. So if we go and have a look at our parallel lines, which angles are equal to one another because of the parallel lines in this diagram? Which angles are equal because of the parallel lines?
Hello, ma'am.
Hello, how are you, Umkholo?
I'm fine, and you, ma'am?
I'm fine, thank you. Do you want to answer?
A1 is equals to
Yes.
B2.
Hey, you are on fire, my girl. Well done. That's lovely. Okay, so as Omokolo says, brilliant. A1 and B2 are equal to one another because of alternate angles, right? So if we can learn to see these things before we even start answering the questions, it's going to help us so much. Yes, I see A1 and B2, says Daneo, alternate A1, B2. Yes. So a lot of you are putting those answers into the chat. Well done. All right, this is going to help us with the first thing. So now let's go and have a look at the question. They have asked us to prove that PAB, triangle PAB, is similar to triangle ABC. Right, so I've got the lines drawn in different colors, but if I just get rid of that and not the angles, and I now go and highlight my triangle. So let's leave this one in yellow. Whoopsie, its line is a bit skew there, but anyway, never mind. Let's go and highlight this one in blue. Whoopsie, skew lines. There we go. There are our two triangles. Can you see that we've actually already proved our similarity, because we've got two pairs of angles that we can already show are equal to one another. We can conclude that the third angles will be equal because of what reason? Can anybody remember what that is? That final last reason after we've got two pairs of angles. What are we allowed to conclude? Not parallel lines. It's not because of parallel lines, I'm afraid. Not angle. Although that's a good one. I understand why you're saying that. There we go, Luam. Okay, angles in a triangle. That's it, let's say. Yes, angles of a triangle. Okay, because the angles of a triangle sum up to 180 degrees. Okay, so if you recall from the other day, the way in which we set this out is very important. We have to begin by stating the triangles we're working in. So we write in triangle PAB and triangle ABC. Right now, they've told us this information about the tangents and the parallel lines, but just have a look at how this ties together with what we know. All right. Remember, we said that because of tangency, we had angle B1 and angle C equal to one another. So look here. All right. Angle C in triangle ABC is over there. It's the last letter. Can you see that it goes with angle B in this triangle? It makes sense because B1 and C are equal. All right. And again, look at A and B2. Okay, so A over here and B2 over there. Can you see the order of the letters? All right. So we can see that we're on the right track, and angle P and angle A have to be equal to one another because of the remaining angles in a triangle. Okay, so the first thing that we are going to say here is B1 equals C because of tan chord theorem. The second thing that we are going to say is that A1 equals B2 because of alternate angles. And then we mustn't forget to name the parallel lines because PA is parallel to BC. So now we can conclude the last pair of angles is going to be angle P and angle A2. And they are equal because, like you said, the angles of a triangle sum up to 180. So that is equal to A2 angles sum in triangle. And remember, we are not allowed to use the sum of the angles of a triangle as reasons 1 or 2. We're only allowed to use it as our third reason. Okay, if we slip it in number 1 or number 2, then we're not going to get any marks for what it is that we're trying to do. Okay, so now that we have proved angle, 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 we can state, therefore, triangle PAB is similar to triangle ABC, and our reason, angle, 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 like so. Okay, so can you see there is your grade 8 and your grade 11 work coming into play here in Matric Euclidean Geometry. All right, how are you feeling at this point? Is it a thumbs up, thumbs down? How's everybody feeling? Is it making sense? Good, thank you, Sibonga and Claire. All right, lovely. Good stuff. Okay, so we've proved these triangles are similar by angle, angle, angle. Good, well done, everybody. Nice, okay. So now on to the next part. Who remembers what the next thing that we need to do is? What am I going to write as a result of proving similarity? If you want to unmute and talk, you're more than welcome. What's the next thing that I need to write in order to be able to answer question B? Good, Lihle. Good, Cornelia. Well done, praise. Okay. What's the next thing that I need to write? Can anybody unmute and tell me so that I can answer question B? What's the next step after proving similarity? Okay, so Teddy, you're onto the right idea. We've got to start talking about the corresponding sides. Can anybody remember what do the words corresponding sides mean? Let's go up here and let's talk. Up here, what do the words corresponding sides mean?
It means they okay, non familiar got it.
It's okay, Samkela. Well done for trying. What do the words corresponding sides mean for us?
Like corresponding sides, when like two sides of a triangle basically share the same side.
Very close, very close. When we are talking about, yes, corresponding sides are in the same proportion. Are corresponding sides in the same triangles? There's a nice question. Are corresponding sides, I'm actually going to put it into the chat. Are corresponding sides in this, there we go. You guys are clever. Are corresponding sides in the same triangle? You're all saying no. Good. I'm glad you're all saying no. Excellent. Quite right. Corresponding
in a way
sides.
they are.
When you say in a way they are, what do you mean exactly, Samkelo? You're quite right. No, they're not. Corresponding sides are sides that are opposite angles of the same size. Okay, so they are sides opposite angles of the same size. Okay, so remember, when we prove that triangles are similar, we are proving that there are 3 angles in the one triangle that equal 3 angles in the other triangle. Okay, so when we say that sides correspond, let's just get rid of the blue and the yellow. And I'm going to show you using other colors what I mean by this. Okay, right, so opposite angle B1 in triangle PAB is side PA. Side PA is opposite B1. Okay, so side PA corresponds with side BA in the other triangle. Okay, that is because PA is opposite B1 and AB or BA is opposite C, and B1 and C are the same size. That's why they are corresponding sides. Okay, they happen to be in the same triangle at the moment because they share side AB, but that's not always going to be the case, right? Another example, if we now have a look at side PB. Side PB is opposite A1. Side AC is opposite B2. All right, so these are also corresponding sides because they are opposite angles of the same size. Okay, so that's what the words corresponding sides mean. Okay, so when we're talking about corresponding sides, they are sides in different triangles that are opposite angles of the same size. So after we prove triangles, that's it. Correct, Tomakelo. Tokomelo, sorry, I pronounced your name incorrectly. So after we prove similarity, as we've done here, we always have to go, our next step is going to be to write the corresponding sides as a proportion. So if you recall from the last time, it was the first 2 over the first 2, and the second 2 over the second 2, and first and last over first and last. Is there anybody who wants to tell me what to write in this case? So using what we've got down here, whoopsie, using what we've got down here, all right, that one over there and that one over there, can anybody tell me what it is that I should be writing now when I want to write my corresponding sides as a proportion? You're welcome to unmute and speak. Don't be shy, guys. Even if you get it wrong, it doesn't matter. We're all here together.
Ma'am.
Yes, Omaholo. Nompumelello's put it into the chat, but go for it, Omaholo.
TA over AB
Mm-hmm.
is equals to PB over AC
Mm-hmm.
is equals to AB over BC.
Oh, you clever girl. That's wonderful. Well done. Okay. It doesn't matter that you changed the order there. So you went first and last. So you went first two over first two, and then first and last over first and last equals second two over second two. That's absolutely fine. Not a problem at all. What's the reason here?
Corresponding sides in proportion.
That's it. Good. Well done. Okay, so the minute they start talking about the sides of these triangles, like they do in this question here that I've just highlighted in blue, and certainly in this one over here, which I've also highlighted in blue, they want us to write the corresponding sides in proportion. Okay, so that's always going to be our next step after proving similarity. Okay, matrix, and then what we need to do is after we've done that, use a highlighter and go and highlight the letters that they want you to use, or the sides they want you to use, rather. So PA with PA, all right? And then AB over here with AB over there. And here we've got AB on this side, so that's AB over there. And here we've got BC, and here we've got BC. Okay, so that makes a nice pair that we can now use. All right. Can I scroll up a bit? Yes, I certainly can. Yes, Sharon, I just want to look at Nompumelello's answer before I go on. Nompumelelo said PA over AB equals AB over BC equals PB over AC. Nompumelelo, that was brilliant. Okay, very, very nice. Thank you so much for that brilliant answer. Okay, there, I'm just scrolling up a little bit again. Sorry, and then I'm going to scroll down. Nhlanhla, is that okay? Yeah, well done, Nompumelelo. That was brilliant. Nhlanhla, can I go down again? Are you ready? Cool. All right. And then don't forget to take screenshots as well, guys. Okay, so now that we've done that, now we can write. So therefore, PA is to AB is the same as AB is to BC. Okay, so remember our fractions. It really helps, I think, when we do it like this. Okay, so we're saying numerator is to denominator is the same as numerator is to denominator. That's the equivalent of what we are saying, and that's why it's true, and it's all right for us to do that. Okay. Latani, no, you can actually write that as well. So you can write proved by similar triangles. Okay, so yeah, not a problem. All right, so now that we've done that, we can go and do the last bit. All right, so question C. Again, grab your highlighter, AP. All right, so this is AP over here. I'm just putting a line on top. BP is this one over here. I'm putting a line on top. AB over there. Let's grab a different color. Let me make this into green. Okay, so AB is over there. So here's AB over here, and then AC is over there, and then AC is over there as well. Okay, so now we can see that instead of us wanting us to use the first and the last fraction, now they want us to use the first and the second. So all we have to do is literally just write that down. Okay, so here, AP over AB equals PB or BP over AC. And now what do they want us to do? Okay, if you have a look, who's changed places? There are two sides that have changed places. Which two sides are they? Which two sides have swapped places with one another? That's it. That's it. Okay. BP and AB. There we go. All right. So we can see that they have switched places with each other. So we have cross multiplied. We're allowed to change places. So now that we've done that, we can then conclude that it's okay to write AP over BP is equal to AB over AC. And again, if we use numbers, it helps us to understand what we're doing. So 1 over 2 is the same as 5 over 10. If I switch 2 and 5 around, I'm saying that 1 over 5 is the same as 2 over 10. Okay, so that's why it is okay for me to do that. All right, that's it. Well done. Okay, now, I see someone's put a message into the chat that they don't understand. Sharon, can you explain to me what it is that you don't understand? Where did I lose you?
Ma'am, can you please explain the whole of B? Because I didn't understand
Okay, so
the
I'm
whole of
writing.
it.
Okay, so I'm writing the corresponding sides in proportion. Right, so remember, corresponding sides are opposite angles of the same size. Okay, so do you remember I said that PA and AB corresponded with one another because they were both opposite angles of the same size? So that's why they are corresponding sides. Okay, because PA is opposite B1. Okay, this is opposite B1. And AB was opposite angle C, and angle B1 and C are the same size. And PB is opposite A1, and AC is opposite B2, and they are the same size. Okay, that's why they are corresponding sides. And AB is opposite angle P, and BC is opposite angle A2, and they are the same size. That's why they are corresponding sides in the same proportion. Okay, because they are opposite angles of the same size. All right, and then from there, you would obviously need to do whatever manipulations it is that they are asking you for. Okay. Yes, Teddy, go for it.
Good evening, ma'am.
Good evening.
that
How are
one-
you?
Good, thank you. And yourself, ma'am?
I'm fine, thank you.
Ma'am, this one is a bit tricky, right? Because now, if AB, we could have used angle C, right? But we could have looked at the size of angle P. If angle P was equal to angle C, then we would have referred BC as angle C, right?
Okay, so if angle P was the same size as angle C, then both side AB would be opposite both of those angles. But that's not the case here.
Okay. Okay, ma'am. Thank you.
Okay. All right. So let's carry on and let's go and have a look at a question that's just a little bit more difficult than this one. All right. How are you feeling now? The majority of us. How are we feeling? We're feeling good. We're feeling not good. Thumbs up, thumbs down.
Yeah,
How do we
let's
feel?
see, guys. Remember, you are muted when you're not speaking to teacher Lee and I. So please mute yourself. Thank you, guys. Y'all are awesome people. Looks good, teacher Lee. Look, my people are
Yes.
understanding.
Does. Clear. Oh, good. Oh, I'm so glad. I'm so glad you're feeling positive and happy about all of this. Brilliant, brilliant, brilliant. Okay, so let's go down and look at something that's just a little bit more difficult. And I'm going to go through this very, very, very slowly with you guys, okay? Sometimes what they do is that they become really, really mean in Euclidean geometry, and they do something like this to us. Here they've given us circles, two circles, ABC and ABD, and they tell us that they intersect at A and B respectively. So that's where the circles cut each other. First, they tell us that AC is a tangent to circle ABD. So again, we see that word tangent, okay? So when they say to us that AC is a tangent to circle ABD, they are telling us that for a specific reason. All right, so similar to the last question, when we see the word tangent, what do we start thinking about? We start thinking about tan, chord, theorem. Okay, so let's go and highlight tangent AC. There it is. Okay, it's a tangent to the smaller circle, ABD. So the point of tangent C is A, all right? Where do you think the chord is? What line do you think the chord is? There's the tangent. Which line do you think is the chord? Okay, AD is a chord, absolutely. What other line is also a chord? There are two chords. AC, okay, but that's in the other triangle, that's in the other circle. So remember, AC is a tangent to ABD. Okay, we're trying to look for tan chord theorem here. Okay, BD is also a chord, AB is a chord, absolutely. Okay, why is AB important for us? AB is important for us because if AC is the tangent, then what we've got here, let me just highlight it for you, is we've got a chord, AB, all right, and that chord subtends an angle in the alternate segment. So I'm trying to highlight AD for you now and BD. So in other words, which two angles are equal? Matrix, because of this. Which two angles are equal? So AC is the tangent.
A2 and C1.
Say again, Faheen.
It's A2 and C1. Angle C.
Okay, it's not angle A2. Angle A2 is not the angle between the tangent and the chord. Sorry, Faheen. You were very close, very, very close.
It's A1 and D, ma'am.
That's it, A1 and D. Good. Okay, so the rest of you, it's angle A1 and angle D. Good. Okay. Can we all see that now? Okay, AC is the tangent, AB is the chord, and chord AB subtends D at the circle. So A1 and D are equal to one another. Right, that's why they're telling us AC is a tangent to the circle. Let's just have a look what you guys are saying in the chat here. Okay, that's it, A1 and D. Good, well done, very nice. Now, they tell us, let's use a different color. Let's just change that to yellow. Now they tell us AD is a tangent to circle ABC. So AD is a tangent to circle ABC. So let's rub out these lines over here. We'll leave the angles that are equal because we obviously need those for similarity. Let's rub that one out as well. Okay, and let's go and highlight AD. So AD is this line over here, and it is a tangent to the big circle. All right, so can you tell me which line is the important chord in this case for us to use tan chord theorem? Which line do you think is important here? Which chord do we think is important? If AD is the tangent and we're talking about circle ABC, which line do we think is the chord? That's it, Lucy, that's it. It's AB. Okay, it's AB. There we go, let's highlight AB. Okay, and remember, chord AB subtends an angle at the circle. There we go. There's our angle at the circle. So which two angles are going to be equal to one another because of tan chord theorem now? There we go, Tina. Beautiful. Straight away you got that. Fantastic. So angle A2 and angle C. 100%. Can the rest of us see that? Okay, so if angle A2 is the angle between the tangent and the chord, it will be equal to the angle in the alternate segment, which will be angle C. Very, very good. Okay. Yes. Good. I'm sorry, I'm just looking at the chat. Very nice. Well done. All right, so now what I'm going to do is I'm going to rub out these lines and I'm going to leave the equal angles that we have managed to find. Okay. All right. Let's just get rid of that in there. And now we are good to go. Now what they say to us is prove that. And here we see something that we have seen before. It's a proportion. BC over AC is equal to AB over AD. What didn't they ask us to do first? Normally, when they ask us to prove proportions, we've done something else first. What is it that we haven't done here? Can anybody tell me? What haven't they asked us to do yet?
Ma'am, they haven't asked us to prove the triangle similar.
That's it. Bang on. Beautiful. Absolutely perfect. They have not told us which triangles to prove are similar. Exactly. We haven't been asked to prove similarity. So this is an extra step that we need to do before we can even begin to answer question A. All right. We now have to prove that there are two triangles that are similar to one another, right? Which two triangles do you think they want us to work in? Which two triangles do they want us to prove are similar? So again, you can put it into the chat or you can unmute. Which two triangles? ABC and ABD. Yes, Fahim. That's it. Yes, ABC and ABD. Perfect. Perfect, 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 perfect. Well done. Well done, everybody. That's excellent. Okay, so let's go and highlight them. Okay, I'm going to highlight triangle ABC. And I'm going to highlight triangle ABD. There we go. And they share this common side AB again. All right, but we know that that's perfectly okay. All right, so we must begin part A, not by writing down the question, all right, because that would be a statement that we were making. We have to begin by writing down the triangles that we are working in, right? So we would say in triangle, and you guys said ABD and triangle ABC. Okay, so now, first things first. Can someone tell me one of the angles that I can use? We've proved them already. We've got them there. We've got the yellow ones. We've got the green ones. Can someone tell me what I should write? So you can either put it in the chat or you're welcome to unmute. Okay, 100%. So either we can start with D and A1, absolutely, or we can start with A2 and C. All of you are correct. Absolutely brilliant. Okay, so let's say we decide to start with A2 and C. And I would say that A2 equals C because of tan chord theorem. Similarly, I would say that angle D is equal to angle A1 because of tan chord theorem. Now I need to conclude about the remaining angles. So if I go back and I have a look, I can see that angle B1 and angle B2 would be the remaining angles in each triangle. So now I can state there in triangle ABD, it's B2. And in triangle ABC, it's B1. Okay, and then here I can say angle sum in trim. Now I need to write, that's an angle sum and triangle. Now I need to write that now I need to write my statement for similarity. Is it okay for me to use just any old order? Can I say ABD and ABC without thinking it through? Am I allowed to do that? Or do I have to consider this very carefully? No, absolutely good. I cannot just write anything. I cannot just write anything because I'm going to make my corresponding sides from the order over here. So I've got to make sure that my order is correct. So I want to point out to you what I did, and you guys can do the same thing. Again, this is where color helps us so much. So there is our yellow triangle ABD. Can you see I put angle A2 over here, angle D over there, and angle B2 over here? All right, so I wrote this triangle first, and I put all the angles that came in that triangle first in my list over here. Then over this side, I had triangle ABC, and then I put these ones second. So these were the angles from triangle ABC that were equal to the angles in ABD. So this helps me a huge amount when they don't tell me the triangles, so I can get my order right. So if I decide to follow the order of my letters and I decide to write A, D, B over here is similar to triangle, what order am I going to write the next three letters in? That's it, Tina. Yes, yes, Lucy. Yes, good, well done, C-A-B. Good, very nice, Matrix. C-A-B, I'm following my order over there. And then I mustn't forget to write angle, 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 like so. That's it. Good, you guys are brilliant. Excellent, Matrix, well done. That's brilliant, brilliant, brilliant work. Okay, so I've gone A, D, B, and that means on the other side, I've got to go C, A, B. So these are little things that we can do along the way that just makes our life so much easier when it comes to writing these triangles, because up at the top here, whoops, I nearly dropped my pen. Up at the top here, where I'm putting a, let me just get a different color. Let's go with that. So up at the top here, the order is not important. Okay, you can write any letters over here. But here, down at the bottom, okay, here, where I'm drawing a circle around them, here, your order is very important. Okay, so order is important. Okay, and the order is important because that is what we are going to use to write the corresponding sides in proportion. And if we mess up the order of the letters, we will never, ever, ever be able to make the proportion that they've asked us to prove. We'll never, ever be able to write this thing over here. Okay, so we won't be able to answer the question. So very, very important that we get our order correct. Okay, so now Omogolo did a great job last time of telling me which sides to write in proportion. I would like, I'm just going to move these down. I would like somebody else, because Omogolo, you are brilliant, girl. I just want to give somebody else a chance to tell me what to write when it comes to the corresponding sides in proportion, just like Omogolo did earlier. Can anybody unmute and do that for me, please?
Let's go. Teacher Lee is spreading the love, guys. Oh.
Let's give
Anyone.
Paul a break and someone else give it a try. Even if you get it wrong, it doesn't matter.
Yeah,
We're here to help you. We'll guide you back on track again.
definitely. Oh, Teddy's here. Hi, Teddy.
Hey, Teddy.
Ma'am, we will look at the sizes of the equal angles and then we'll identify our corresponding sides.
Okay, so Teddy, absolutely. So which sides correspond with one another?
Okay, AB will.
In which triangle are you working at the moment? Are you working in the green one or are you working in the yellow one?
In the green one, ma'am.
Okay, all right. So AB corresponds with?
What BD?
Good, well done. Very nice. Excellent, excellent. Now go back to the green triangle, pick another side, and then write more corresponding sides for me.
And then side AC will be equal to side AD.
That's it. Okay, corresponds with AD. Very nice. Well done. Okay, and then the last ones, go for it. You're doing this so nicely.
CB will be equal to AB.
CB. Yes. Corresponds with AB. Okay, very, very nice. Okay, that's because AB and BD are opposite angles that are the same size.
Yes, ma'am.
Okay, so in other words, AB is opposite angle C and BD is opposite angle A2, and C and A2 are equal to one another. Lovely, lovely, lovely. You've done this beautifully. Now, the other way that you can do this, Teddy and everybody else, and you're going to see you're going to get exactly the same answer as you've written over here, is you can look at the order of the letters in what you've written here with this circle around it at the bottom, okay? So if I look at the first two letters and the first two letters over here, can you see it's exactly what you said, you told me over here, Teddy? Okay,
Yes,
so the first two letters AD, I'm just going to put it over here. Over the first two letters CAAC, it doesn't matter. Okay, you told me that. That's perfect. Now have a look at the second two letters. So I'm going to use green now. There's DB and there's AB. There's DB and there's AB. That's exactly what you told me. Okay, so that's brilliant as well. Okay, so first and last, so DB over AB. And then you can do first and last and first and last. So when I say first and last, I mean AB and AB and C and B like that together. Okay, and this is exactly what you told me. You told me AB and you told me CB. Okay, brilliant, brilliant, brilliant. So now this is going to be equal to AB over CB. What's my reason here?
Reason will be corresponding sides in proportion.
That's it. You are brilliant.
Thank you.
Okay, very nice, Teddy. That's wonderful. Now let's just go back and compare our answer to what it was they wanted us to prove. So they said BC over AC, BC over AC. So there's BC and there's AC over AB over AD, AB over AD. There we go. It works out perfectly. All right, so now I'm going to grab those. I'm going to say, okay, so AD over CA is equal to AB over CB. What did they want me to do? BC over AC, BC over AC. So now they are asking me to make a comparison between the denominators and the numerators. So therefore, BC over AC. I'm putting denominator over denominator. So this denominator over that denominator is equal to this numerator over this numerator. Okay, that's what they wanted from me. Okay, very, very nice, Teddy. Well done. How's everybody feeling? Are we feeling good? Good. Oh, lovely. Well done.
Wow,
Okay,
majority of us are feeling good.
that's great to hear.
Yeah.
Good, good, good. I'm so glad. All right. Well done, everybody. That is brilliant. Brilliant, brilliant, brilliant. Okay, so let's finish this off and we'll do the last question and then you guys can go and try the quiz for this evening. Lovely, Sarah. So nice to see 2 thumbs ups. All right. So now they want AB squared. AB squared. So AB squared means AB times AB. So if we go back to this original thing that we wrote, okay, we're always referring back to this. AB times AB. There's AB and there's AB. So that's how we can get AB squared is equal to BC times DB. So it's this one over here and this one over here. So for this part, what they want us to do is grab the yellow ones. So I'm going to write BD over AB is equal to AB over BC. Doesn't matter if we switch the letters around. And now we're going to cross multiply. So I'm going to multiply AB with AB. That's going to give us AB squared. And then I'm going to cross multiply these two, and that's going to give me BC times BD. Okay, and there we go. We've done it. All right, well done, everybody. This was a really, really, really difficult question. Certainly one of the most challenging things that they would expect us to do in Euclidean geometry. So yeah, well done to all of you for the progress we made this evening. That's really, really awesome. Okay, are there any questions? Teddy?
Ma'am, does it matter when we're saying therefore ADB will be similar to triangle CAB. Doesn't matter in which I know you will write them according to their similar sizes, but does it matter if I started with B and so on?
No. So what is important is that the order always matches. So if I wrote ADB the first time, but the second time I choose to write DBC, let's say I do that. So I go, sorry, DBA, beg your pardon. So if I go, let's just change that quickly. So if I go DBA, so here I went this one first, D, then I went B, then I went A. I've got to do the same thing on this side. So I've got to go A first, okay, because A goes with D, B goes with B, and A goes with C. I've got to do that.
So it doesn't matter which sequence you write it, as long
The
as
sequence,
they match.
exactly. Okay, so if you start with A in the one, you've got to start with C in the other. If D is in the middle of the one, then A has got to be in the middle of the other. If you start with D with the one, then A has got to come first as well. Okay, that's the idea. Okay. All right.